Everyone, thanks for joining us for our session today on Synergi Electric. I think everything is working. We are recording. I think my audio is working all right. All right, let's get going here. So you've probably heard the Distributech is postponed until May. So maybe I'll see you then face to face or mask to mask perhaps. And so we'll just continue on this month with our training sessions. We are working on version 616 to get posted at the end of this month. So hopefully the last few days of January or early in February, it'll be on the portal. We're looking to have it wrapped up, I think the 26th or something like that of January. And things are looking pretty good. A lot of stuff in this update. So we're looking forward to getting it into your hands. Okay, so let me get this out of the way. So we're going to cover, finish up Arcflash that I didn't get to last week, and then we'll get into the data lake, which we looked at that a little bit quite a while back, and then we might get started in EA automation. And so we are sitting right here between these two. So we're going to finish up Arcflash and then get going into these items. We'll definitely be doing more next week in this area with batch files. A lot of great things you can do with your data and automate and making your own studies. There's all sorts of things you can do. So we'll spend some time on that, and then we'll get off into protection. Okay. Looking at my back door here, but Synergi, and this is the today's build. And there's a few things I want to show off that we've got in place. One of them is one of these things that's surprising that it's taken us so long to one of these things that seems, wow, this is a great feature to have. It's simple to do, and I don't know why it took us so long to do it. But previously, if I would run something like a load flow analysis and want to look at the results, we run load flow, and then and if you have a question or anything, please chat away. We'd run load flow and then go over here to the results tab and look at something like the voltage, maximum voltage, color the map, and then if we wanted to see the values on the sections or look at the sections that are a particular color or whatever, we would go back to the model tab and then go to the sections right here, and then we would see the colors, section IDs, results, that sort of stuff. And then you could sort these columns, put in filters, export this stuff to Excel, all sorts of things over here. Well, we put that same it's a splitter and this control down here on the results tab. So now you don't have to go back and forth. So once you run an analysis, then there's a little bit less room up here for all the results to show up. But what's nice about it is now you can explore these values up here and pick results, and then down here the section list, the values are all going to get updated, and so you can sort and do all that stuff off the list on this tab right here. So it seems like a super obvious great improvement that took us quite a few years to stumble upon. So that's a nice thing in the version 616 coming up. While I'm looking at these voltages, let me point out what these are again, because it came up in a support case last week. So years and years ago, back in the Scott and Scott days, there was like a balanced load flow and a biphase load flow. There were two different load flows, and the balanced one was based on the Westinghouse T&D handbook. So they were kind of arithmetic ways to do load flow, and it would result in scalar values. And so that was the balanced load flow. And it made sense back then. There wasn't a lot of data. Models were greatly simplified. And so back in, oh gosh, we started this around 96. We built the biphase, the detailed biphase engine for doing load flow, and it does everything. And so we eliminated the balanced analysis and the biphase analysis back then and created a single simulation system. So everything is biphased based on all the details of the lines and everything. But the need for a balanced number was still there. So, 90s, 2000s, even today, when you look at load flow results, oftentimes you want to say, all right, what's the voltage on that line section? You don't really want to know every single phase value. You just want to know a single value. So that was what we called the balanced value. And the way that we calculated it was we would take the biphase numbers coming out of the analysis, and we would rotate them usually phase B and C. We would rotate those back 120 degrees so that they lined up with phase A. And then we would average the complex phasors. So A, B, and C were kind of in the same direction. We would average those, get a single voltage, and that was the balanced voltage. And that is the balanced voltage. So when you go and look at volts out right here, that's what that is. And let me bring up a section editor here. Look at the results tab. And so this volts out, if these are very close together, but so here, if you were to take these three numbers, if things are really unbalanced, then if you average these scalar values, you wouldn't necessarily get this average right here. Because we are taking a vector average. We're doing that rotation thing and getting the vector average. A lot of times, if things are fairly balanced, then numerically this turns out to be the average of those scalars, but it's just kind of a coincidence. Okay, so why am I getting into all this? There's a lot of applications in Synergi, and a lot of them are doing things, presenting, making decisions based on the voltage. And so over the years, as we've built these applications, in the 2000s, something like a switching application, contingency or optimal switching, those sorts of things, would make the decisions based on the balanced voltage. But over the years, probably since maybe, my gosh, 2005 or so, we've been converting applications to use the minimum or the maximum phase value. So instead of, if we're like contingency, for example, instead of making switching decisions based on this voltage right here, this balance value, it would make switching decisions based on the minimum voltage of any of these phases. And so most applications in Synergi work that way, but occasionally we run across some that have not been converted yet. And so volt var optimization is one of those. It's over on the performance tab. I think we'll look at that later on. And it's going in there and saying, all right, how far can we drop the voltage on a section to increase our VAR support, or to have to lower our voltage for CVR types of situations. And we were showing the balance. We were looking at the difference between the current balanced voltage and the lowest voltage, and so that wasn't right. So we made the change in 616 to look at the lowest of any phase versus the lowest allowable voltage. So that's an example where that's a lot of rambling for that, but it's important. It comes up a lot, and you can see it here. Volts out is going to be balanced, and then the max and the min are going to be the individual phase max, individual phase minimum. And in the load flow reports at the bottom, you can see all the phasor values, and then here on the results tab towards the bottom, there's actual values. So here we have kV values, amps, and then we have the angles listed here. And so those are always, that's the way the calculations are done. Under the hood of Synergi, that's where everything is worked using these things and using ohms. And then we kind of present stuff in volts and all of that. Okay, so results tab. This is a big deal for 616. Another thing that's really nice now is if you want to look at results on a section, you've seen the results boxes. We put a little pop out here now so that you can say, all right, results box, and then you can automatically, or you can quickly choose the kind you want. So if I want volts and amps, I can do that quickly. Before, it was just results box. You'd get the box, and then you'd have to drop this down and pick the result you want. So now you can do it in a single step. It's a simple thing, but I think it saves a lot of time, and it also saves me the distraction. I can just kind of not even think about putting up a results box and stay focused on what I'm trying to do. And then you may have seen that there is a result box, and so if you do that, look at that, because hold on a second here. Let me just yeah, that's a little bit of a step backwards. It used to be that you could have multiple results boxes for a section, and that was great. I think that was an accident actually, but it's very handy to do that. So I'm going to write that down. It looks like this thing is going, when you go to the section and you click on a results box, if it's already up, it just changes the type. I think I'd prefer to have a second box come up. But the point right now is that there's a results here, and that is going to show the results set, which is whatever it is that you're coloring the map with. And that's nice. Works, which is not working here. We should see is this value should, so sorry to drag you through some testing of 216 or of 616 here. Yeah, so these results are changing. That should change. And so I'm not sure what's going on. I thought I looked at this earlier. Yeah, so we'll get that fixed. It's very nice, because a lot of times I don't want to annotate just because I don't want a million numbers on the screen. I don't want to bring up the section editor and look at the results entry at the top of that. And so I can just have a scattering of these results boxes around and be able to look at Arcflash numbers or whatever it is. Yeah, this thing is not doing well at all, because that result set should be populated. We'll get it working. All right, what else? Results box. And then the last thing I wanted to show you here is some early work. Well, it's probably premature work, because I don't think a lot of folks are going to be dealing with this yet, but it seems like it is coming. I know a lot of utilities are talking about it internally. I've asked some of you during our various web meetings if it's something that you all are discussing. And it seems like it is a very popular topic, and that's residential car chargers. And so we have data in place now. So if I go to the customers here, and we talked about this during the secondary session and secondary modeling. And so what we did on the customers tab is, one thing we did was kind of clean this up now. So we've got load here. We took the battery stuff off of this tab. Now there's a storage tab where residential battery systems would be. And then we have a car charge now. So the default's going to be no charger. And I think, I don't know what the numbers are. It seems like some utilities were hitting about 100 per substation maybe. And I know a lot of utilities are far below that. I don't know, in central PA, I do see electric cars around. So why do we do this? It's complicated, right? There's a lot going on with this. And as the residential charger number starts to increase, there's all sorts of ways that customers could utilize these smart grid rates, selling back, all kinds of stuff. And so we want to have the data in place, the models there, so that as these things start to evolve, we're not starting at ground zero. We've already got stuff in place, and we can start to listen to what all you need and develop the model more, put in applications, and so on. So today you can set up a charger, you can put in the rating here, you can use a charging rate, you can use a profile, which would be the time of day profile. And then there's a global spot where you can go in and say, regardless of this, turn on all the chargers or turn off all the chargers so that you can kind of look at worst cases. But so anyway, that's in 616, and it's an area that we're going to keep working on with you all. Now I want to get my notes here, and we're going to jump back into Arcflash. I did look at this. I just have to be careful about dragging browsers onto the shared screen. So here we go. So whoops. I looked at this OSHA thing. Somebody pointed this out last time, and I need some more help with this because the 1910 is huge, and I think the person commented that it was in Appendix E. So it's great that this is all. It looks like it's all public information, and so I haven't spent a lot of time looking at OSHA. I don't know why they have so much stuff is in this. I don't know, was it 1910 when it was developed? I don't know, but there's a huge amount of information here. So if there's some more guidance on this, I think it was relating to single phase, Arcflash with single phase lines or something like that. So we're happy to dig into this and put it into the analysis if we can get a source behind it. So today we're going to look at this standard, or we looked at the standard last time. I've got it rotated. It's based on regression. Regression is based on all this data that was collected and all these coefficients that were generated. And so this standard is full of these tables. And so if we look at the, and you should definitely get this standard. If you're doing Arcflash 2018 standard, you definitely want to buy this and have it to refer to. I think it's very well done, except for the math. I think our math is a little better. A lot of these equations can be simplified much more, and it's kind of painful to work through these. So just taking another step could consolidate these equations so that they make more sense. But besides that, the organization, everything is great on this thing. So this is what Synergi Electric uses, and I'm going to go into the technical reference, and we do have a summary here in the tech ref. There we go, fault and protection, Arcflash principles. It's right here at the top, the 2018 standard. And so this is what we go through, and we're going to calculate these arcing currents, and it's based on this equation, which looks I think less intimidating here than that big long thing that was in the standard. But it's a whole bunch of coefficients. These Ka coefficients are out of that standard. This is bolted fall current that we calculate, and these are some settings you put in. So this gives you the arc current at different voltages. And so the way that this works is that come through, kind of step ahead here and look at, all right, where are we going to be calculating the arc current? And so if our open circuit is voltage is more than 2.7 kV, that means it's case 3. And for case 3, the arcing current is the second estimate number 2. So we go back up to here, and estimate number 2, it's a regression. So we're going to take, all right, what's the arcing current if we were at 14.3 kV, 2.7 kV, and that determines this thing. And these are a little more than the printed coefficients, because remember, the bolted current from your circuit is incorporated into these coefficients. which plays a role in these values. But this ends up being a constant, and then this ends up being a constant here. And then this is going to be the voltage on your feeder minus 14.3. So that's going to be a ratio, and then we add in this thing. So this is just a simple regression thing based on these complicated coefficients. So that's how it works. And so we end up with an estimated current, and then we go through and determine, all right, how long is that arc going to last? So that is done using the protective devices on your circuit. So the fuses, reclosers, breakers on your circuit. And so of course the curves, the settings need to be legitimate for that, so that for a fault of whatever the arc current is, traveling up that line is going to get interrupted, and we're going to determine the correct arc duration. And then we take into account the enclosure, and then we go in and determine the incident energy. So this is how much energy would be produced at that location. So the amount of fault current, how long that lasts, is going to determine how much energy is the lineman or electrician would see there, or hopefully not a bystander. And then it cycles around. We go through a second calculation. So there's an update. I'm not seeing it in here, but we update the value, then we go through those two steps again, and then we end up with a final energy. So a lot of stuff in here. It's kind of regression after regression. So it's multiple stages of using these regression coefficients that IEEE developed for that standard. Okay, so that's how it works. And then when we want to do the analysis in Synergi, we go to the protection tab. Get my notes here again, sorry. Oops, protection tab, and run Arcflash. And the first time I run it, there's a bit of a delay because Synergi is looking at all these protected devices, and they all have various settings. They have curves selected. So we need to go to the protection database where we have all that curve data and load in the curves. So you see a bit of a delay there, and then the curves get loaded and the analysis finishes. So we can go here to Arcflash 2018, and the information then is going to be, how the incremental energy is a big deal. So incremental energy, we can turn this on, the legend bar, to see this. And I think a lot of utilities are trying to stay below 4 calories per square centimeter. So you would be looking for everything in your circuit to remain below the 4. Maybe substations are an exception to that. Maybe out on the feeder it's below 4. It seems like that's the case. So that's the goal. And so in our model here, down in this area, we've got some sections that are above that. And so maybe that's a problem. So this is the maximum of any of the configurations. And I talked last week about this standard accounting for horizontal, vertical, enclosures, and then enclosures with material that's put in front of that. But I think there's 5 different configurations. And so those 5 configurations are listed down here. So if we wanted to look at vertical, look and see what that stands for, sorry. But that the incremental, or the incident energy for that is here. And so all the enclosures, horizontal, vertical open air, I know that one. You can look at that. So the worst is the one that's listed up at the top. But if everything is vertical open air, then I don't know how you would combine horizontal and vertical. Guess we don't have the max of these two. But anyway, there's sets. There's like sets of results for each of these configurations here. Okay, so the report for Arcflash is similar, and just a lot of data here. Vertical open, closures, and so lots of details. And so this is going to you'd have to be deep into it to want to go to this report, because there's these are just the calculations, because a lot of folks do that, and we have had utilities and consulting companies do comparisons with Synergi, and things are in good shape as far as I know. Everything matches up, and we appreciate that, because we have corrected problems over this has been around since it's been 3 years, 4 years maybe. And so it is vetted and it's in good shape. But you can see the the 600 volt, 2.7, 14.3 regression points in here. And so these are all just calculations, so that you can hopefully have points along the way where you can compare results. And if you're doing it, you're probably doing it in MathCAD, I would guess. So that is the report. Tool here that is useful if you are looking at Arcflash is this protection evaluation application. And if you run this, it's going to give you a list of feeders, and each section is listed. We have fault values, the maximum fault value, and then the interrupt. What is going to be doing the interrupting, and so information about this fuse. Probably put those in a different order there, but the fuse, it's an 80 amp fuse. It's going to interrupt in 0.15 seconds, 0.015 seconds, sorry. And so you can kind of look at this and see, all right, what's doing the interrupting? How are my sections handled? And then we can also look at this on the map. If we go, and there should be a protection evaluation right here. And there is an interrupt milliseconds. So you can see the interrupt times on your circuit here. And there's other things that show, what devices are protecting what areas and everything. But this is pretty handy if you're in Arcflash to get those, to try to see what is resulting in those interrupt times. In our case, that new cove feeder is up here. New cove is this little feeder right here. And our protection in this sample model is really bad. There's a bayonet fuse sitting up here outside the substation on this transformer right here that seems to interrupt just about everything on this feeder, which isn't good. So a lot of unhappy customers. So we could go in and say, all right, this needs to be a 65, or put in something else, or take it out. And that's going to impact the Arcflash, because now it's going to be faults on sections down here are going to be interrupted by something else, and that interrupt time is going to be different, which is going to set off a whole chain of things in those calculations to result in a different energy and so on. If it's a faster interrupt time, does the energy go up or down? And I find that not intuitive all the time. It seems like it's fairly non-linear, where sometimes I might have a faster interrupt time and it makes the energy worse. But you all who deal with this stuff, I'm sure, have a better feel for that. Yeah, let's go over the settings here. Yeah, thanks. So the settings for Arcflash here. And go to settings. So the big one is which standard are you going to run? And we haven't talked about the 2012 standards, but it's 2002. I guess it goes back to 2002. It was updated in 2012, and it's all calculation based, where some folks developed a physics model, and so that's all based on physics. 2018 is based on testing. Okay, so the settings here. This is I don't think this is in the 2018 standards. This is going to be it's just going to look up personal protective equipment level based on the energy. And so I could be wrong. Maybe it's in this 2018, but it's definitely in the 2012 all over the place. And so that was one of the goals is, all right, if somebody's going to go out and work on this line, then what sort of equipment do they need to wear and to protect themselves? Here is how the fault is clear. So we can use arcing current or bolted fault current, and that's going to have an effect on the interrupt time. And this is a bit deep. I'm struggling here a little bit, but the arcing current is going to be calculated going through stepping into the standards. We calculate the arc current. We use that current then to look upstream and device until we look at all of them, and the one that's going to interrupt the fastest, that determines the clearing time. So you can use that arcing current calculation, or you can just use the bolted fault current, which would be straight out of fault analysis. And then here is where I've found this is an area where things can kind of go haywire. Yeah, the minimum fault clearing time is 10 milliseconds. So if something happens, and it'd be tough to do that, but if you had some device for some reason that, well, maybe I had 100 here. If I had 100 here, there may be devices that could interrupt faster, and they would be ignored. It's going to be at least 100 milliseconds no matter what. So we've ran into cases, these values may not be very good just based on how the defaults came into play during Synergi updates or whatever. So you want to look at these things. The maximum time, so we're always going to assume that something is going to interrupt the fault within 2 seconds, right? I've got 2,000 milliseconds here. So something's going to play a role within 2 seconds. And then this number right here is a modeling to help with modeling, because you may have a model where the protected equipment is in the substation, but you don't have the substation loaded. And our sample model is a good example here, because our breakers are in the substation. And so if I were to load just the feeder alone without the substation, this thing's not going to be in the model. And so this 200 milliseconds here is going to be for that case. So if I don't have anything upstream, we're going to assume it's cleared in 0.2 seconds. And then this checkbox, I don't remember the history behind this. I'm sure it was for working with a client, and you just specify the clearing time. And so this would probably be for troubleshooting or looking at a specific case, because a lot of times you're not looking at Arcflash everywhere. You've got a certain area where you're looking at it, and so it's very legitimate to say, okay, I want to specify the time, and so that's what that is. Okay, now then the equipment tab. This is a lookup table based on, these categories are in the 2012 standard, and we are using them in the 2018 for specifying the working distance, believe in the gap. Yeah, so the working distance and the gap, we probably should put a note in here somewhere, but the ones that are used in the 2018 standard. So it's how far the worker is from the potential from the hazard. This is going to be the gap between the contacts, I believe. Oh, sorry. Yeah, that seems like a big distance there, but I believe that's what that is. And this X is a coefficient, and I don't know if it has a physical meaning, but it is, I apologize, I don't think the X is used in the 2018. So it's the working distance, the gap, and this is the enclosure. So the calculations that involve enclosures, these are the dimensions of that enclosure. So you can kind of go in and fill in this table for equipment, lines, and so on. The label, it's intermittent. It seems like some folks it doesn't work for. I think it is probably something to be avoided at this point. Back in 2002, it was there's a lot of folks who are printing labels based on Arcflash, and I'm not sure that's being done now. If it is, let us know. I think the format of this label is probably old. But anyway, that's what this was for, is you could come in and check this, and then you could send a label to the printer that had this stuff in it. So those are the settings for Arcflash. And so, well, we can look at your model if you're still getting these values that aren't looking too good. I'm happy to take a look at that later. We want to look at Arcflash on a TCC, and we're going to be coming back to TCCs later on. But if you want to see an Arcflash curve, you can grab a device and got a fuse here, and we can put Arcflash curves on here in two ways. One way is to do a right-click, add line, Arcflash line. So that was quick, wasn't it? Add line, Arcflash line. This one here is going to be based on the 2002 standard. And if you double click on it, you get this inspector that comes up, and you put in these values, which are very much 2002 standard values. And from these, this line can be calculated. So this is an 8-cal line based on a 20-inch working distance, and if we wanted a 4, we could do that. Update, shifts it down. So that's how we do it. Now, if we want a line for the for current standard, the 2018 standard, since it's not calculated, we really don't have a way to generate the curve. So what you have to do here is add a line, and then just pick line here. And that's going to be a generic line. You can grab the corners of this thing and position it. So you can position it in there, and then you can add labels to these things. Double click on it. And then I've got to turn on the text labels, or the leader lines and the boxes here. So you can put these on here. You can visually check coordination yourself. Today this is not a part of check coordination. So if you run check coordination, which is coming up in one of our future sessions, it's not going to look at the coordination of these lines. That's something that's on our to-do list. We just haven't done it yet. Definitely looking forward to getting it in here. And then another thing that comes up a lot is folks using Arc Pro or other systems, to get that data onto the TCCs and Synergi. It would be nice to have a way to pull that data in. And our protection database is open, and some folks have mastered ways to get the data into that database, and then they can select and bring those curves up in their TCC, but it's kind of an ad hoc thing. Okay, we're going to move on. I've been long-winded here. Yeah, if you have a blank TCC, so the way that I do it a lot, well, one way you can do it, sorry, is if you go to the protection tab here and click on New TCC, you should get a blank window like this. And then if you want to add an Arcflash curve, you just right click and do add line in Arcflash. Should get something here, and you might have to pan and zoom around. And if it doesn't come up, let me see here. It's showing. If it doesn't come up, I don't know if there's a way to get at it. Then that may be a problem. So if it's still not coming up for you, William, then we'll have to work with you. It may be that those values in that in those settings are the defaults are just out of whack, and it's showing up out in the boonies somewhere or not showing up at all. And I don't see a way to get to, because right now I can double click on this line, but if the line's not there, you can't do that. And at the top of my head, I don't know how to get to this. Note here. And then the one that should definitely show up is if you right click, add line, and just put in line right here. So that one should definitely show up. And then you have to grab the top or the bottom 10%. So the corners, the edges of the line, and you can drag it around. But there's no calculation behind this line. Let me plow ahead here into yeah. So if you right click on a device like a fuse or something, so with no TCs tab up here, if you right click on a TCC and you can say right click on a protected device like a fuse, then you'll get this add to TCC menu, and you can click add to TCC, and then it should come up here. Now, if this is blank, that means your protection database is not connected. So that's going to be up in the preferences, and we'll get into that for our protection session, which is let me get into protection, session 12 here. So after you all endure my batch scripts and macros session, then we'll go into protection and TCCs, and then we can get into that protection database. So if a fuse is coming up blank, I think that your database is not connected. Yeah. And you can contact support too in the meantime, or me. I'm happy to help you out. But client support, email, text support, and Kevin or Brennan or Frank or Johnny, someone definitely help you out. Okay. Now then, a lot of stuff that we're going to get into now with the batch data lake and stuff, and I don't think they're too difficult to use. My hope is that we're all going to have a better understanding of what's available, so that all these little tools and things that you can leverage, you'll know where they are, and then if somebody says, well, can you do this? Well, you say, yeah, we can do that. And maybe you have to scratch your head and remember how, or reach out to us and we'll help you out. First thing we're going to talk about though is data lake, which we covered earlier during the load session. But I want to get into it again just because there's a lot there, and it's a very useful tool. So I'm going to get a window. I've got a folder here, Junkyard, where I just keep stuff temporarily, and we're going to put in a spreadsheet. So go in, and I want a new Excel worksheet here. So the training data lake, and I'm using the XLS with an X on it, and so that is the, I guess, the current Excel file format. Now, we just last week we had a client who had an update, IT update for Office, and it just stopped working. And what we found out was that, okay, they could go and save this thing as just an XLS file. And the difference is that when Synergi is going to go and talk to this spreadsheet, there's two drivers to choose from. And we select a driver based on this extension. And so I don't know if they just took the X off of that or if they went into Excel and saved it again without the X on it. But when you do the save in Excel, there's like 50 different formats you can choose from, and so there's various forms of X and L and a bunch of other stuff. But so you can do a save as in there. But anyway, hopefully it just works with the XLSX. And by the way, there have been, it seems like, an unusual number of Office issues with access and other things that I think have been acknowledged as bugs and issues by Microsoft, and they've fixed them. Hopefully these will all kind of clear out, and we won't have any issues moving on. But if you do run into weird problems that are just popping up with Access or Excel, then please let us know. Maybe we've run into it with someone else, or hopefully we can figure it out together and let everyone know. All right, so there's my spreadsheet. Now then, we're going to go in here and we're going to use a new feature of the data lake to save our loads into that spreadsheet. So we're going to go here to the forge ribbon. This is where the data lake is. And we'll click on this, and I want to export a spreadsheet. You can see we have other options here. We're just going to focus on spreadsheets. And we're going to export, go to next. And then we have a list of all these data beds, is what we call them. There's schemas, and the new one is down here, all loads. And you can even do all loads for all years if you want to, but I'm going to go to that. And then I need a DSA for the data lake. So the easiest way to create that, remember I guess the basic way that you would do this is I would cancel here, go to the power pole, go to my data source aliases, and I would create one, and then you'd step through that wizard, give it a name. Where's the data coming from? It's coming from Excel. It's got data lake data in it. And you'd step through that and click apply, and then it would show up in this list. But an easier way to do it is just hit the browse button here. And then here's my junkyard, and there's my training data lake right there. So I can select that, click open, and if you remember back to the DSA stuff, you can have a name that's more useful to you besides the file name. The file name comes up as default. It's pretty intuitive there, so I'm just going to stick with that. So now it's created a new DSA for me. I'm saying I want to send my loads to it, and now I can click on finish. So it's fast, and I'm going to come back over here, and then I'm just going to double click on this. Okay, so here's Excel. Front page is just, so the page that Synergi added is this load 107 right here. And we've got a list of all the sections. I think it's going to be all sections that have any sort of load on it. And then the load type, distributed load, spot load, large customers, projects, customers. So everything should be in there. And then across here is just all the details about the load values, connected values, and so on. So there's a bunch of stuff in here. So what we could do is, if maybe we have load setup that we want for next year. Maybe we want to do something with growth. We can use functions and stuff of Excel and make changes to these. Or maybe I just want to save this so that I have an archive of what the loads were on my model for this study or this year or whatever. But so lots of data here. For a sample model, there's a lot in here. We got 1,200 rows. This was a client request. So that says this particular data bed is new in 6.16. Whenever you're using data lake, always close Excel because Synergi will very likely get in a hang-up with Excel with a file sharing problem. And I ran into that this morning when I was getting ready, and I had to go to the task manager and just shut down Synergi. We're going to try to detect a potential problem, but a lot of times it happens in that driver I was talking about, and so we don't really know. So things just hang up, and that's a pain. So be sure to close Excel when you're working with the data lake. All right, so that is the loads. Now let's try something. Well, another one that's pretty useful here is a different use case. Let's go into data lake again. I want to export to a spreadsheet, and the demands, my meter demands, are here. So the MTR 101 is meter demands, and so now I've already got this data lake DSA set up, so I don't have to mess with that anymore. I can just finish. And if we go and look at the spreadsheet again, these are all the meters in my model, and these are the demands. And I've got some as amps and power. So if I was doing a forecasting study, then this is where I might come in and just multiply the values, or maybe there's some sort of formula that I want to use. So I can change these values, and then to get them back into Synergi, be sure to close Excel after you've made those updates. And then you go into the data lake, and you're going to do an import from a spreadsheet. What I'm using is at the top. There's a bunch of others in my list here. I think it's not good. Figure out why that's showing up. But for the data lake that we've been using, you can see my two data beds are here. And so if I want to import loads, I can check that. If I want to import demands, I can do that. So I click on that, go to a next, and then finish, and then all these meters will be updated. So it's very it's very easy to go and modify data outside of Synergi and then pull it back in. Let's go through a case here that's we talked about a little bit. This on the DER tab, this DERQ. I think I just talked about it because so anyway, let's run through a case using this thing, because it does use one of the data beds in the data lake. And the data lake schemas or data beds, you can see on the data lake under this little down arrow, the schema is right here. And so these are all of the data beds we support. We were talking about protected devices for Arcflash. That's one. So a fairly new one is this section 103, I believe. Yeah, this has got all the curves for a recloser in it. So very important thing is if you have data sets that you want to get in and out of Synergi, then let us know. Send us a note, because we built the data lake tool so that we can quickly add these things, and that's been happening as clients have let us know what they need. We put it in here, and then everybody can use it. So there's a lot here. You could go into Excel, create a spreadsheet, and put these in as the column headings. It's a whole lot easier just to save it out. Even if you don't have any protection data, protected devices, you can still export a protection 110, and that's going to set up your sheet and schema for you, and then you can just fill it in. In the spreadsheet, you can also have extra columns. So Synergi is just going to look for these named columns here. but you can have all kinds of columns. It can even do calculations. So on that demands data lake, you can have other columns that are calculating the demands, and then Synergi will pull in the results of those calculations. So it's a good combination of using Excel with Synergi. Okay, so I'm going to go and do this export one more time here. I'm going to do a quick export to a spreadsheet. I want to grab all the generator. So I'm going to use a DER 101 to create all my generators in a spreadsheet. So I'm going to do this again. Now then, let's take a look at this over here in Excel. Oh, okay. So these are generators that are in the model that got dumped into the spreadsheet. And so what I want to do here, that's fine. Let's keep them all in here. These are customer. I'm going to delete those, and I can change the values on these. And in fact, I'm going to get rid of those. Get rid of these large customer ones. You'll see why in a minute. So maybe my model was set up, and maybe I had added these generators in, and now I've got just a bunch of standalone generators in this. And I think those spaces are fine in there, but all right. So now I have a list of generators. All right, so I'm going to use the multiple editor, which we talked about previously, and I'm going to build multiple editor. General tab. This is not a tool I use a whole lot. So the general, delete generators. So this is going to delete all my generators. So don't be careful. Apply that, and now then all these little solar generators. There's a couple of synchronous generators that are gone, but they're all missing from the model now. So then we can go over here to the DER tab, and let's run this DERQ. So my settings for the DERQ. This data lake spreadsheet has a ton of stuff in it. Let's go back to the training data lake, DER 101. Sure, I've got Excel closed here, so DER 101. So this is the data lake that I want to use for my DERQ analysis. And then I'm going to run this DERQ. And so I had stripped off all the generators from my model. Now I'm going in using that spreadsheet, and I'm adding them in one by one. So I added that first 1 megawatt generator, and I could see my delta voltage, loading it a whole bunch of stuff, added the next generator, and so I could start to see what is going on with my before and after. I think I mentioned it before. This is kind of it's a little bit corny because not corny, but it's hard to use here because I've got multiple feeders in here with generators all over the place. So I don't see like a trend of voltages going up, because if I were to sort this by feeder, I would see it. But here it's so I could do a little work on this to yeah, there we go. So I can get my feeders. I've got them in backwards order now, but so the before and after. So that's using the DERQ analysis. Now, if I want to get those generators back on the model, and this is just to show you how it works, show you how the DERQ analysis works, which is a kind of a flashback to several weeks ago. And then going back to the Forge tab, if I want to pull those generators into the model, turn this off, go to Data Lake, do import DER 101, and do a finish. And so now I can see the generators are back in here permanently in the model. That use case is not really very useful. I could see where if you had a bunch of generators, you might want to see what it's like if you step them in, one by one. That makes sense. But you wouldn't want to use data lake to take a bunch of stuff out and then put it back in. You're either going to with the same values, because there's a lot of stuff on these generators that's probably not in the data lake schema. And there's a ton of details in here that are going to be lost because we deleted the generators. Only the ratings and the locations were in the data lake. And so if we had things like under descriptions, inverter voltage references, stuff like that, we would have lost it. But hopefully that's helpful for you to see how this data lake works. Next week we're going to jump into using EA automation. Very powerful tool. Lots of folks are using it, and then we'll do batch analysis and some other stuff. So